Dear students, welcome to today's class. So last few days onwards, we have explained about trigonometric ratios and identities, multiple and submultiple angles, compound angles, the concepts and formulas, all those things I explained, and various problems are also we have discussed. Okay, now in our this video, I am going to explain about transformation, trigonometric transformations. So what is a transformation? Transformation means change of the whatever may be that some change. See here, these formulas are familiar with us. Sin of a plus b plus sin of a minus b. Sin of a plus b formula we know. Sin of a minus b formula we know. Cos of a plus b formula we know. Cos of a minus b formulas also we know separately. If you add them, then what happens? That is the main point behind this concept. Okay, so here sin of a plus b plus sin of a minus b, then we got sin a 2 sin a cos b. Here between two trigonometric functions, what is there? Plus is there. Whatever may be the two trigonometric functions, what is the sign we have? Plus. Then between these two trigonometric functions, what we got? Multiplication we got. Here between two trigonometric functions, plus is there, here minus is there, here plus is there, here minus is there. Now what we got here? Product we got between two trigonometric functions. That means the plus and minus will becomes multiplication. That is called transformations. Okay, now so the proof of these formulas are very easy. Okay, now so how can we prove? Very easy proof. See here, sin of a plus b formula, just expand here, sin a cos b plus cos a sin b. So this is the formula we have, plus sin of a minus b formula, sin a cos b minus cos a sin b. Okay, now what do you get? Plus cos a sin b minus cos a sin b. So here these two will get cancellation. Okay, now sin a cos b become 2 sin a cos b. That is the proof of the theorem. Okay, now similarly we can prove this also, sin of a plus b, sin a cos b plus cos a sin b under bracket minus sin of a minus b, sin a cos b minus cos a sin b. So if you see here, if you open the bracket here, minus sin a cos b plus sin a cos b will get cancelled, minus into minus will become plus, cos a sin b, 2 cos a sin b. That is the proof of the second result. Okay, now coming to third result, cos of a plus b, cos a cos b minus sin a sin b plus cos of a minus b formula, cos a cos b plus sin a sin b. Now if you observe here, minus sin a sin b plus sin a sin b will get cancellation, cos a cos b plus cos a cos b formula 2 cos a cos b, right. That is the proof of the second result. Coming to third result, cos of a minus b, cos a cos b plus sin a sin b minus cos of a plus b formula, cos a cos b minus sin a sin b. So if you observe here, cos a cos b minus cos a cos b gets cancelled here, minus into minus, plus sin a sin b plus sin a sin b, 2 sin a sin b. The only thing you have to remember is here sin of a plus b minus sin of a minus b we wrote, but here you have to make the reverse, sin of a minus b minus, cos of a minus b minus cos of a plus b. So if you write down, generally if you write down like this, what happens? Cos of a plus b minus cos of a minus b, then we will get minus 2 sin a sin b you will get. Okay, now that means if you reverse it, you will get minus here. So if you want to avoid minus sign here, you will write down cos of a minus b minus cos of a plus b. Now using these formulas, can we get some more other formulas? Can we derive the formulas using these formulas? That means somewhat still simplification formulas can we get it. For example, in our future, in next problems, if you get any this type of problem, for example, sine 12 degrees plus sine 13 degrees, what happens? This is sine 12 plus sine 13, how much this value? Understand how to write down that value. So how to write here plus is there, how to make it into. So can we get some more easier formulas comparatively this? Yes. And one more thing what you have to remember is, for all these formulas, you have to write in a reverse order also, you have to remember. So reverse order means what? Whenever you got 2 sin A cos B, you have to write, remember it as a sin of A plus B plus sin of A minus B also. And that means, for example, if you got like this 2 sin A cos B, 2 sin A cos B. So you should be in a position to write like this, sin of this is nothing but sin of A plus B plus sin of A minus B. So wherever if you get 2 sin A sin B, wherever you got 2 sin A sin B, so you should be right in a position of cos of A minus B minus cos of A plus B. That means all these formulas you have to remember from left hand side to right hand side and right hand side to left hand side. In both the direction you have to learn. Okay now? Right. I hope that you understand these formulas. Let us see the actual real set of formulas that we are going to see. Okay now? So let us continue our class. Welcome to this concept. Now we have this known formula, sin of A plus B plus sin of A minus B is equal to 2 sin A cos B. That formula is there already, we know the derivation. Now what I am going to do is, let us take A plus B as a C, A minus B as D. That means A plus B, let us take C, A minus B, let us take D. That means now I am going to express these formulas in terms of C and D. Okay now what about A value, what about B value? Let us see that. So if you want to get A value, just add these two equations, that is 2A is equal to C plus D, A is equal to C plus D upon 2. Again take A plus B is equal to C and A minus B is equal to D. If you want to B value, now just subtract here. So this is minus plus minus. Take cancellation, 2B is equal to C minus D, B is equal to C minus D upon 2. Now rewrite the formula with the C and D variables. Okay, now here the variables are A and B. Of course, they are angles. Now rewrite these formulas in terms of C and D. Let us see what happens. So now your formula is, this is equal to sin C. In place of A plus B, I wrote C. This is a sin D. Sin D. So this is equal to 2 sin, in place of A, write C plus D by 2. Okay. In place of B, write C minus D by 2. Okay now, in place of A, write C plus D by 2. In place of B, write C minus D by 2. Okay. So this is one of the first formula of transformations. Sin C plus sin D is equal to 2 sin C plus D. That means sum of these two angles upon 2 into cos of C minus D by 2. C minus D upon 2. Understand? Sin C plus sin D is equal to 2 sin C plus D by 2 into cos C minus D by 2. That means in between these two signs, plus sign is there. In these two trigonometric ratios, we got into. This is called transformation. This is called transformation. Now let us see some more results. That means we have 3 results. No, For those three results, let us see what happens. I will see that. Okay, na? So let us continue the class. Just like sin C plus sin D is equal to 2 sin C plus D by 2 cos of C minus D by 2, how we got? So the remaining formulas also we can derive. So just like sin of A plus B minus sin of A minus B is equal to 2 cos A sin B formula we got. Cos C plus cos D, that means cos of A plus B plus cos of A minus B is equal to 2 cos A cos B. In place of A, I wrote C plus D by 2. In place of B, I wrote C minus D by 2. Cos C minus cos D is equal, that means cos of A plus B minus cos of A minus B is equal to minus 2 sin A sin B. In place of A, I wrote C plus D upon 2. In place of B, I wrote C minus D upon 2. So here we will get minus here. So if you want to avoid those minus, write C minus D as D minus C. So you know that trigonometry ratios of negative angles. Okay. Then how to remember these formulas? Remembering the formulas is a very important. Okay, now always this total formula setup should be in your mind. The order also you have to remember. The order is always remember. First sin C plus sin D. Sin C minus sin D. Cos C plus cos D, cos C minus cos D. Sin C plus sin D, sin C minus sin D. Cos C plus cos D, cos C minus cos D. That you have to remember, that order. See here, for every there the formula starts with 2. Of course, last one is minus 2. Last one is minus 2. So here sin cos will come, cos sin will come, cos will come, sin will come. Like that you have to remember. That means first one sin cos, cos sin, cos sin. That is the order you have to remember. Sin cos, cos sin, both cos, both sin. That means next these are all same. C plus D upon 2, C plus D upon 2, C plus D upon 2, C plus D upon 2. Here C minus D upon 2, C minus D upon 2, C minus D upon 2, C minus D upon 2. That is fixed here. This order also maintained. So total setup you should keep it in your mind so that you won't confuse the formulas. Okay. So whenever if you got cos C plus cos D, so cos C plus cos D means both cos will come, cos will come. Cos C minus cos D means, remember here, cos C minus cos D means both sines will come, both sines will come. Of course, minus 2 will be there, C plus D by 2 will be there, C minus D by 2. If you want to avoid a minus sign 2, here C minus D by 2 becomes D minus C by 2. Okay, now, so this is the setup framework of that formula. Okay, now, so let us see some more concepts. We have one of the very beautiful problem here. So the problem is, if cos x plus cos y is equal to A and sin x plus sin y is equal to B, then prove that tan of x plus y by 2 is equal to B by A, sin of x plus y is equal to 2ab upon a square plus b square, cos of x plus y is equal to a square minus b square upon a square plus b square, tan of x plus y is equal to 2ab upon a square minus b square. Then how to prove this? So this problem will be useful for for as a result also, as a formula also you can remember this problem. That means in place of A and in place of B, some value will be given, and from 5, 6 to 1 or 1 by 2, 1 by 3, then they may ask to find out tan of x plus y by 2, like that. See here, so first here what is given? So this is a cos x plus cos y is equal to A is given, and one more thing, sin x plus sin y is equal to B is given. Then how to get x plus y by 2? First thing what that remember that should come in your mind is how to get x plus y by 2. Yes, apply the formula cos x plus cos y, x, y. Can we get x plus y by 2 and x minus y by 2? Surely we will get. So here what we will get? Cos x plus cos y is equal to 2 cos x plus y by 2, and cos of x minus y by 2 is equal to A. Sin x plus sin y is equal to how much? 2 sin x plus y by 2 into cos x minus y by 2 is equal to B. Is equal to B. Okay, now we want B by A. Here B is there, here is there. second equation upon first equation. You call it as this is a first equation and it is second equation. Second equation upon first equation. What you will get? So this is by 2 cos of x plus y by 2 into cos of x minus y by 2, that is equal to a. So any more cancellations? Clearly see here, 2 will cancel, x minus y upon x minus y by 2, x minus y by 2 cancel, sin by cos, so this is nothing but tan of x plus y by 2 is equal to b by a. That is the proof of the first problem. Okay, now happy. Then but what about this? Here x plus y, here x plus y, here x plus y is there, by 2 is not there. By 2 is not there. Then how to do that problem? By 2 is not there. How to do that problem? Then we make use of the multiples and submultiple angles. Okay, so we will use of the multiple angles. Okay, na? So let us see that. We have one formula, sin 2 theta formula in terms of tan. See here, I will write here sin 2 theta formula in terms of tan. Actually sin 2 theta formula 2 sin theta cos theta. In terms of tan, what is the formula? 2 tan theta upon 1 plus tan square theta. 2 tan theta upon 1 plus tan square theta. Just like cos 2 theta formula, cos 2 theta is equal to 1 minus tan square theta by 1 plus tan square theta. Okay, now? Right. What is tan 2 theta formula? Tan 2 theta is equal to 2 tan theta by 1 minus tan square theta. So that is the formulas we have. See here, this is a multiple angles. What about submultiple angles? So that is equal to what about sin theta formula? If it is sin 2 theta, 2 tan theta upon 1 plus tan square theta. If it is sin theta, here we will get tan theta by 2 upon 1 plus tan square theta by 2. Okay, now? So that is your formula. Now, what I am going to see here, wherever theta is there, I will put x plus y. Substitute x plus y, sin of x plus y is equal to 2 tan of x plus y by 2 upon 1 plus tan square x plus y upon 2. Okay, now? That's all. So this is equal to 2 tan of x plus y by 2. Already we know tan of x plus y by 2 is equal to how much? B by a. This is b by a. This is 1 plus b by a whole square. So if you observe here, b square by a square, 1a will cancel, 1a will come in the numerator, 2ab by a square plus b square. Okay, now? So remaining, so this you take it as a homework and this also you take it as a homework. Just like how I did, wherever theta is there, first to convert it into submultiple angle, that is cos theta is equal to 1 minus tan square theta upon by 2 by 1 plus tan square theta by 2. Tan theta is equal to 2 tan theta by 2 by 1 minus tan square theta by 2. Wherever theta is there, substitute x plus y. Wherever theta by 2 is there, substitute x plus y by 2. Then you continue, you will get the result. Okay, na? I hope that you understand this solution. Let us go for some more problems. Welcome to one of the very, very interesting problem. So this is the absolute value of the expression. So what is the value of this expression? Absolute value means what? If at all, if you get any negative values lost at plus minus 5, minus 6, minus 8 like that, you have to write it in a positive sign. That's all. So remember this formula, this is tan pi by 16 plus tan 5 pi by 16 plus tan 9 pi by 16 plus tan 13 pi by 16. Then how to proceed this problem? Okay, so now what I am going to do is, whenever this pi by 16, 5 pi by 16 type of this thing came now, so immediately students will get tension. Okay, so no need to tension. So lest I will take this as a, let theta is equal to pi by 16. This implies 8 theta is equal to pi by 2. So both sides I multiplied with 8 theta. So wherever 8 theta came, you can write it as a pi by 2. So now your problem will change to, so I will make it as a y. Let us call it as a y. Y is equal to tan theta plus tan 5 theta plus tan 9 theta plus tan 13 theta. Okay, na? Right. So wherever theta is there, I wrote pi by 16. Right, clear. Now here tan theta okay, tan phi theta okay. Let me reduce these two values, tan 9 theta plus tan 13 theta. See here, I will write down rougher as it is. Tan 9 theta, can I write it as tan 8 theta plus theta? Any problem? Tan 8 theta plus theta, no problem. 8 theta means how much? Pi by 2. So this is pi by 2 plus theta. So this is equal to minus cot theta. Tan 90 plus theta, second quadrant, therefore minus cot theta. Tan 13 theta. Tan 13 theta is equal to tan 8 theta plus 5 theta. Again 8 theta means how much? Pi by 2. So this is also minus cot 5 theta. Minus cot 5 theta. So therefore your problem is changed to y is equal to tan theta. Tan 9 theta value is equal to how much? Minus cot theta. So I wrote here minus cot theta. Plus this tan 5 theta. Tan 13 theta value minus cot 5 theta. Okay. Tan theta minus cot theta plus tan 5 theta minus cot 5 theta. Very nice. Again 5 theta can be changed into 5 theta. Still we can change into 5 theta anything something more less than 5 theta. Right. Still we can reduce 5 theta. How? Tan 5 theta. So this is equal to tan of 8 theta minus 3 theta. Tan of 8 theta minus 3 theta. That is equal to tan of pi by 2 minus 3 theta. This is nothing but cot 3 theta. See here 5 theta, I wrote tan of 8 theta minus 3 theta. 8 theta means pi by 2. Tan of 90 minus theta means cot theta, first quadrant. Still I can reduce this problem as y is equal to tan theta minus cot theta plus tan 5 theta, I can write it as cot 3 theta minus cot 5 theta, I can write it as tan 3 theta. Okay na? So very nice. So almost I reduced the values here. Theta, 5 theta, 9 theta, 13 thetas are there. Then I made it into theta, theta, 3 theta, 3 theta. I reduced. Yes, enough. Okay, then we can start the problem. Now this y is equal to, see here, we have one formula. Cot 2a formula we can have cot. So these two I can combine. How? If I write down, if I wrote cot 2 theta formula, cot 2a. So cot 2a formula, cot of a plus b, cot a, cot b, that means cot square a minus 1 by 2 cot a. Cot a plus b formula, cot a, cot b minus 1 by cot a plus cot b. Therefore, cot 2a formula, cot square a minus 1 by 2 cot a. So here if you observe here, if I write down 1 by tan theta, so this is equal to 1 minus cot square theta by 2 cot theta. Okay now, but it is in the reverse order, it is there. So I will write down like this, 1 minus, so this is a cot theta minus tan theta, I will write down. So this is a cot 3 theta minus tan 3 theta, I wrote it as. So this is equal to, y is equal to minus, see here, cot theta minus tan theta. I will write down tan theta as 1 by cot theta. So this is cot square theta minus 1 by cot theta. But so this is becomes 2 cot 2 theta plus this is also 2 cot 6 theta. So this is also 2 cot 2 theta, 2 cot 6 theta. Okay na? Right. So this is our last step. Let us continue the problem. So this is equal to, y is equal to 2 times cot theta. Cot theta means sin 6 theta, sorry, cos 6 theta by cos 6 theta. Again cot 6 theta we can reduce as, we can reduce like this. Cot 6 theta, therefore this is a cot of 8 theta minus 2 theta. This is equal to 8 theta means pi by 2 minus 2 theta. This is equal to tan 2 theta. So cot 6 theta we can write it as tan 2 theta. Tan 2 theta minus 2 cot 2 theta. Okay, na? Right, beautiful. So next y is equal to 2 common you take, tan 2 theta minus cot 2 theta. Okay, na? So this is equal to y is equal to 2 into cot 2 theta, that means 1 by tan 2 theta. Oh, sorry, cot 2 theta. So this is 1 by cot 2 theta. Again you will get here reverse order you will get, that is equal to minus 2 times cot 2 theta, 4 theta. So this is a 4 theta. Okay, na? Right. So this is equal to y is equal to minus 4 cot of 4 into theta value is how much? Pi by 16. So 4 4s are cancelled. Y is equal to minus 4. Cot pi by 4 value is 1, minus 4. But coming to absolute value is equal to how much? So that is modulus of 4 is equal to 4. Modulus of minus 4 is equal to minus 4. Therefore, I hope that you understand this solution. So I hope that you understand this class, you enjoyed this class with some more problems on these transformations, and tomorrow I will come before you. So okay, until then, all the best.